Hi, welcome to another episode of Infralytics. I'm Shankar, and today we are going to talk about best practices for implementing observability in microservices environment with Stefan Thies. Stefan is the DevOps Evangelist at Sematext, a provider of application and infrastructure monitoring solutions, and also a provider of consulting solutions for Elastic Stack and Solar. Stefan also has extensive experience in product management and pre-sales engineer roles in the telecom domain. Hi, Stefan. Welcome to the show.
Hi. Thank you for having me here.
Right. Let's jump right into the topic, right? Container-based microservices are used very extensively by organizations to make it more adaptable, the environment's more adaptable, the infrastructure more adaptable and easy to manage. So what are some of the top monitoring and management challenges faced by organizations that are deploying or container-based microservices?
Yes, there are quite a lot of challenges. So some people start very simple with a simple Docker host, or then later on they use orchestration tools like Docker Enterprise and Kubernetes. And what we see here is actually containers add a new infrastructure layer and a new kind of resource management. At the same point, we are in performance monitoring. You get new kind of metrics that you need to monitor. For example, how many containers are deployed and where is which tool running. So what we developed in the past was then special monitoring agents to collect these new kind of metrics on all layers. So you have a cluster node and you get a performance metrics for a specific node. On top you run Kubernetes pods. And in the pod, you run several containers and multiple processes. And the new monitoring agents needs to be container aware. So they have to collect metrics from all the layers. Then the second challenge is the new way of dynamic deployment and orchestration. So you deal with more objects than just servers and your services. You deal with cluster nodes, you deal with containers, you deal with pods, you deal with deployment status of your containers. And as things can be very dynamic, and orchestrators like Kubernetes move your applications around. So maybe an application fails on one node and then the cluster is shifting the application to another node. It's very hard to track errors and failures in your application. Maybe you have a short outage because of something is moved to a new node, but you have to figure this out. So I think the new orchestration tools put additional challenges to the DevOps people to see not only what happens in the applications, also what happens on the cluster level and why things are moving around.
So basically they add another layer of complexity. Earlier it was a physical bare metal, then the VMs. Now you have the containers. That is another layer that you need to look at, both from a monitoring perspective as well as from an orchestration and a management perspective.
Yes, and you have a declarative orchestration layer. Like you tell Kubernetes, you need 3 instances of this application, and you don't care where it runs and how it is deployed exactly. So the cluster takes care of it. If something fails, it might start it somewhere else. Or if it is not able to deploy it because you don't have enough resources, the deployment fails. And these are things people like to be notified about. You cannot say I start 10 databases, but I have only one node and this one node has not enough resources. So there are challenges like that.
So you talked about like the monitoring across the stack, right? From the bottom layer all the way to the application layer through the containers. So when it comes to container-based environments, what are kind of the challenges, the additional layer of monitoring challenges that containers brings in? Like what should like administrators or whoever's looking at that visibility, what should they be looking for?
Yeah, sure. There are metrics on every layer: servers, clusters, pods, containers, deployment status. Another thing I didn't mention, you asked me for the top things that people have to care about, is also log management changed completely. In the past, we used log files and just ship the log files to kind of Elk Stack or to our cloud platform. And today, containers log to the console, and each orchestration tool that has different mechanisms to deal with those logs. And you need a logging agent that is able to collect the container logs and add metadata for it. So with every log line, we add information on which node it is running, in which pod it is deployed, in which container, what container image, and which image version is used. So we have better visibility of the origin of your logs, and it helps a lot with troubleshooting. And next thing that comes to the container deployment is microservices. Typically, architectures are today more distributed and splitted in little services that work closely together. And then it's harder to trace transactions that go through multiple services.
Right.
So transaction tracing is the new pillar of the observability. And you need to instrument your application, because here it's not just metrics and logs. Basically, you add some code for each transaction and give transaction IDs so that you can follow the transaction ID over multiple services. So transaction tracing is also a new kind of tool for observability, but it needs more work to instrument the code. In the past, there were only vendor-specific APIs for that, and there are new standards that allow you to use one API to instrument your code, and so people are more open to add transaction tracing to their applications.
But the tracing, as you said, is a kind of a new, in the sense you're able to see the transaction as it goes through the various services, right? So now, is it a challenge if we have an existing application that you want to bring the tracing into that, versus is it more of a, start from scratch? Do you need to start when you start from the design stage, you want to bring in tracing?
One is, let's say, standard applications like databases. With new tracing standards, the vendors have the chance to add instrumentation code to the tools that they develop. And the next thing is, on your own applications, you have to add the code instrumentation. There's nothing magically that detects all function calls that you do and trace it. So the developer has to add a line of code that says, here starts a transaction, and this is something I want to trace, how long it takes, if it was performing well, or if it had any error, and so on.
So you have the vendor-specific code, you have the in-house do-it-yourself code, and then there is this open source code, right? A lot of people use the open source libraries. How well is tracing incorporated into these open source libraries that are being widely used by organizations?
Yes, there are great projects like the Jaeger agent. It collects tracing calls. It supports multiple backends. One of the backends is, for example, the Elastic Stack. And in that way, you can collect this data. By the way, tracing generates a lot of data. Right. So if you look at the amount of data, we have already a lot of data with metrics. Logs has even more volume. And you can imagine when you trace function calls, you get a huge amount of data that you need to handle. So the ingestion rate of the storage, and later on having efficient queries for that is another point that comes with tracing.
So basically, we talked about the log management becomes a challenge because of all these microservices, and you're also doing the tracing, not just on the metrics and the events, right? But you're also now looking at all these trace files, the data that is coming through that part. Right.
Yes, so, with having more data, people need larger data stores for the operational data. It's often funny that, for example, if you have an e-commerce platform with, 1,000 products, the data is not much. It fits in a small database. But when you have a lot of online transactions on the store, actually the operational data, metrics, logs, and traces produce a much higher volume. So people need to look for good storage for metrics and logs, and therefore we run this software as a service where people can ship logs and metrics and traces in one platform.
Okay, so the whole management aspect of such large clusters, log storage and log, everything becomes a challenge, right? It adds a layer of complexity. to the...
Imagine you run a small Elasticsearch just for product search, and now you add another one for logging, but the one for logging gets much more data. And then your people are busy with maintaining the log management part.
Right.
And you can outsource that with software as a service, for example.
So collecting all these different sets of data, right? You have the event logs, the metrics, and then the tracing data. How do you bring them together? Like, what's kind of connecting them? How do you connect them? Or is there an approach, like a method to the madness, kind of like, seeing all this data sets that we have?
Yes, let's say we produce monitoring agents and log agents. Both tools use the same tags. And that way, let's say we add the Kubernetes node name, the namespace, and the pod name to the metrics, and the same tags go for logging. And that way we can easily correlate the logs and metrics. So you can see a spike in the metrics, you find the same tag for the same container in the logs. And the second thing is the time correlation. So in our user interface, you see a spike in metrics, you open the logs and you can quickly navigate to the logs created at the same time. That makes troubleshooting really fast. You need to connect the dots, and that works typically with having the same labels on metrics, logs, and traces. So internally, whoever builds the service, you need the kind of schema where you say which labels needs to be used for all the containers.
Are there libraries or different approaches that organizations can adopt? Instead of going and reinventing these standards?
Yeah, that's very interesting. I think every vendor has kind of schema, like Elastic has a schema for it. There are other open source tools like Grafana that started with a logging tool called Loki, I think. And they have the same approach. They take the labels from the Prometheus monitoring and attach it to the logs. And we as a vendor do the same. So we have also a schema with the same. But at the moment, I think there is no real open standard. It's like every tool has their own labeling on it, but it follows more or less the same approach. I hope in the future there will be more standards defining this.
Correct. Yeah, the challenge with the different standards is, if they use multiple of this. So let's say if somebody uses both Grafana and Elasticsearch, which I'm seeing a lot these days, right? Users are using both Kibana as well as Grafana for different use cases and so on. So now how do you kind of bring them together, or somebody has to go and kind of standardize on all that?
And with the open source tools, it's a lot of do it yourself. Means you need to sit down and think, what metrics do I have? What labels do I need? And do the same for the logging and for the monitoring side. And with a vendor solution, the vendor thinks about it and you just get it out of the box.
So now we talked about the challenges. So now let's say you went to give like a structured approach kind of to the organizations who want to tackle this, right? And basically with the goal of making their infrastructure more resilient and easy to manage and so on. What would you suggest as some of the approaches? What are the strategies that organizations can adopt in container-based in the microservices environments?
Yes, there are for sure multiple levels organizations have. Some don't have any monitoring and just get notified by the customer about the problem and then they try to fix it quickly. That's the worst level. I think nowadays more and more users are used to have 24/7 services because they're used to it from Google, from Facebook, all the big vendors do this 24/7 thing. And smaller software vendors have clearly a challenge to be on the same level, to get aware of any problem as soon as possible, or even in advance to see potential problems. And what you need to do is you need to start first monitoring. Means availability monitoring. Is your service running? Then you add metrics to it for infrastructure monitoring. Are your servers healthy? Are all the processes running? How is the performance of your processes and containers? And the next level is then application monitoring to see the performance of your databases, of your message queues, and all the tools you use in your stack. And finally, also the performance of your own applications.
Mhm.
When it then comes to troubleshooting, so you recognize some service is not performing well,
Mhm.
then you need the logs. And in the initial stage, typically people use SSH, log into the server, try to find the log file and grab for errors. And central log management is here really the key feature. You need to collect the logs from all your servers, from all your processes, from all your containers, store it in one place, index the data, and make it searchable and accessible.
Right.
And as we mentioned, the thing with the labels and correlation with the monitoring data, that's really a good level for troubleshooting. You see performance problem, you can correlate the data, and then you can also quickly solve the problem. I think that's the road to go. But if you want to be very advanced, you go to the level of code instrumentation and tracing. So you see better the bottlenecks of specific transactions that are faced by your customers. Maybe one thing I didn't mention was, if you run a web service, the user experience is also an important thing to measure. So this kind of, let's say, passive monitoring, you add a kind of script to your browser that measures how fast the pages are loaded, and measure the customer experience in that way. But this is separately from infrastructure monitoring.
Okay, so you're
used more by the back-end developers, and the front-end developers have a different set of tools to monitoring the performance in the browser and see how the web application runs for their users.
Okay. So this is more from a user experience, right? Front-end user experience when they come to either an e-commerce site or any kind of website, right?
That's another approach people start. Sometimes people start just with passive monitoring or browser monitoring to see how is the user experience. But at that level, you cannot really solve the problems. You can recognize the problems, that something is slow, maybe it's the database, maybe something else. And then you need to start to monitor the back end.
Okay. So just to kind of dive a little deeper into this, right? You said passive monitoring versus more, the other approach is more looking at it across both the front end as well as the back end and so on, right? So could you kind of delve deeper, like, what is passive, right? Basically, what is passive monitoring? When you define like just passive monitoring, what is passive monitoring? What is the other recommended approach that you're talking about?
Well, I think the right term for it is synthetic monitoring. For example, you make a HTTP request to a website and you measure how long it takes until the web server responds. So you can run such scans frequently, every minute, every 10 seconds, whatever the resolution is you like to have, and see if the service is running and if it responds in the expected time, like get a response within a second.
Okay.
If it takes longer, then typically you want an alert that your website is slow. That's called synthetic monitoring. Then there is browser monitoring, or let's say digital experience monitoring. Here you add some scripts to your website that measures how long the page loads. And this can be different also from the network where the customer is. So sometimes you might have just a problem in a specific region because there is some kind of internet outage or slow DNS services.
Right.
You cannot fix all those kind of problems, but at least you are aware maybe sales goes down in Europe because there's a major problem with some DNS servers and some shops are not accessible or have a bad performance because of that. It's a temporary problem and hopefully solved by the big internet providers. And and then you have more, let's say, performance monitoring in the back end. Here you install agents on your servers that collect performance data from your server machines and monitor all processes and containers on it. That's also the point where you collect the logs.
Great.
So that takes some time and work to install those agents. The good thing with containers is now, and especially with Kubernetes, you can have one command to deploy agents to all nodes. For example, we use on Kubernetes a daemon set that's a process that runs on every Kubernetes node. and we deploy our agents that way.
Okay.
So there's one command and you have monitored anything.
It makes it easy to collect the data from those various.
Yeah. In the past, when you had multiple virtual machines, you had to install the agents on every machine.
Right.
But orchestration makes it much easier today.
So we talked about this whole back and front end kind of looking at. So, and we also talked about tracing. So that gives us a good segue into observability, right? That's the new term that is getting a lot of visibility. A lot of people are talking about it. So can you talk a little bit about, what is observability? How is it different from just say monitoring, right? What are the key components and so on?
Yes, I think we touched it already. So observability is the whole thing. It's monitoring, where you get metrics, you have logs, and you add transaction tracing to have on the code level visibility. So if you look at synthetic monitoring, where you just ping a server and see if it responds, it gives you not a lot of information. It just tells you your service is running. But if you want to know why is the service not running and where exactly is the problem, then you can improve with metrics, you can improve with logs, and on the tracing level, you can nail it down to a specific line of code or a specific function where the failure happens. And when you have more information, it's much faster to fix it. It's different if you tell a developer, oh, something is slow, they might not know. They look the whole day in some logs and cannot find the reason. But with tracing, you can say this function call is slow, and then the developer immediately knows what to do.
So kind of bringing in the three pillars of observability is like the logs, metrics, and the tracing, right? Kind of at least the starting point for observability. I've also, come across people who want like live testing, right? Testing is a part of the observability. Like you want to be able to test on a production environment to simulate unpredictable problems, unpredictable failures, and so on. So what are your thoughts on those?
Yeah, sure. But what I see with our customers, they have typically a development platform, and this is what we also do. So when we make a pull request, we have the whole CI/CD pipeline that deploys code changes automatically to a development platform, so the developer can check if everything works right. Then people have a staging platform. This is pre-production. So and here you typically run more tests, and then you have your production platform itself. For ourselves, I think we don't run tests on the production platform itself.
Okay.
As you know, that can be kind of risky, but therefore a staging platform is very helpful because you can do all sorts of crazy tests with that. Other companies might have different opinions about it.
Because especially if you go to an online service, like, for example, whether it is Google or Netflix or any of these Airbnb or any of those, it's difficult, right? They design for elasticity, they design for unpredictable failures, and so they want to test in the live environment. They do run tests like in a segment of the live environments to see.
Sure, but they have, let's say, complete different kind of infrastructure than most of the software companies have.
Right.
Let's say many one just, I don't know, something like 50 or 100 servers, and we don't speak about thousands of servers. So those large organizations have of course different challenges and need more advanced approaches, of course.
Definitely. Okay, so let's say an organization has been implementing monitoring for some time. Now, how do they move into this observability, going from just being pure monitoring approach to an observability? What are the challenges that they would face? What are some of the approaches that they can take to address those challenges?
Yes, I see it very well with the onboarding on our platform. So our log management is very well accepted. So people start typically with collecting the logs because this is the first challenge they have. Where do I store all those logs? Should I set up a separate server for it, or do I go for software as a service? So we see that people start collecting logs, and then they discover more features that we offer monitoring, And then they start installing monitoring agents, and they start to ask about specific applications that they want, how to monitor that. And automatically they do more and more steps. And we have now simplified that with what we call auto discovery. For example, on Kubernetes, we discover already all pods on containers and monitor the metrics of it. But what if a MySQL database runs inside of such a pod or container? MySQL has specific application metrics.
Right.
And what we do now is, for integrations that we have already, start automatically monitoring application-specific metrics. So basically, you take your container with our, we have kind of key for a specific application type. So you add a label that you want to monitor this application, and then we start automatically collecting the metrics for the application layer as well, for Java applications, databases, message queues. And I think that's the right approach to automate it, because in the past it was difficult. For every technology, you had to know how to set up the monitoring agent, how to connect it to the database, how to connect it to a message queue, and so on. And with features like auto discovery, we automate the deployment of agents.
Right.
So it recognizes the application type and starts the agent with the right configuration to give you the metrics. One thing you don't need to think about, just tag it and start monitoring.
Okay. So you're using Eager or any of those API frameworks to automatically generate the traces for the applications and so on, or you expect them to?
Yes, well, tracing still needs the manual code instrumentation. So developer needs to do something, but we can support with having a tracing agent that you can connect to and store the data in the backend. Yeah.
So you work with a number of clients who deploy Elastic Stack, either in the cloud or on-premise and so on. So what are some of the issues that customers commonly face when it comes to using Elastic Stack for observability, right? What other components do they need to augment with? What are the other things that they need to bring in to provide that solution?
So very interesting, the history of our company Sematext is we started with consulting around search. So our founder was a contributor to the Scene project, where Solar and Elasticsearch is based on. And from there he started search consulting. And then later with Solar and Elasticsearch consulting. And Elasticsearch is now a tool that is used in the monitoring space a lot. And what we developed very early was monitoring tools for Solar and Elasticsearch. This was actually how our monitoring platform started. And today we have a software as a service that covers all kinds of applications. But from the consulting, we learned we need those tools to track the performance of those search engines and the performance of the servers. We need to tune the disks on the Linux server. So we need to monitor all those things. And yeah, what typically happens is that people face problem with scaling Elasticsearch or tuning the queries or tuning the hardware for Elasticsearch. So we help with all of it. And one other challenge came recently with the commercial licenses of Elastic. It's nice to see the company growing, the tool gets better and better, more reliable. But on the other hand, the company adds also a lot of commercial features which are not available. So our consulting clients ask, how can I add security? I want to secure my Kibana dashboard. There are also open source tools for that available. They have a lot of tools for performance monitoring, like Beats that collect the metrics and store it in Elasticsearch. And yeah, you have really to look what tool you need and what is commercial and what is not commercial. And then customers need to decide if they buy a license from Elastic or if they go to another APM vendor that has a similar or even better functionality in that space and use then a different tool. Also, storing metrics in Elasticsearch, it might be nice and easy to use, but actually if you look at the performance or the volume you need on the disk to store metrics in Elasticsearch, It's much higher than in any other time series database. Because it's made for text,
Right.
and you use it for metrics, and therefore you have storage overhead in Elasticsearch for metrics.
Right.
So what we do under the hood is that we store metrics in a metrics database, and we store logs in Elasticsearch.
So is it something like a TSDB or InfluxDB that is commonly used for the metrics time series databases?
Yes, actually we use Yandex ClickHouse
Oh, ClickHouse, okay.
for our metrics, which is a nice big data store and scalable. The reason is that we need it very scalable, as we run a software as a service for many customers. We looked also into InfluxDB, but the clustering feature is not open source, and we needed really a scalable database without limitations here.
Yeah, but ClickHouse is getting a lot of traction, a lot of interest these days.
Looked to it last year, and we are so far very happy with it.
Okay, awesome. So in terms of scalability, elasticity, and all that, ClickHouse is very easy. Is that easy to deploy, manage compared to, say, other types of time series databases?
I'm not sure if there is big difference in operations, but we look really at the reliability and performance and the storage volume that we need, because all those resources produce costs in the cloud services. So we run our infrastructure on AWS, Amazon, and you can imagine when you need more storage, more CPU, it counts when you run software as a service, and that was also a decision criteria for having ClickHouse.
Oh, makes sense. No, that's great. Kind of series of discussions about starting with just the container-based microservices, then we moved on, talked about the observability, and then finally Elastic Stack, and we moved on to ClickHouse also. So we covered a lot of ground here.
Yeah, don't tell it anybody, it's our secret sauce.
Hey, so we'll try to keep it. Great. Hey, thanks very much for taking the time, Stefan. So appreciate it. Appreciate your insight. And why don't you give a shout out to your website where people can find more information about your company and so on? You want to
you just go to www.sematext.com and you find there the information about us, about our consulting service, about our metrics databases, about our log management. It's very easy to get started.
Great. Thank you so much, Stefan. Thanks for taking the time to share your thoughts on this critical topics these days. Thank you. Well, that's all the time we have today. Thank you for joining me. Don't forget to subscribe to our YouTube channel and also provide your review. We want to help users like you improve your IT, security, and business operations. If you're interested in learning more about an easy and cost-effective way to email, PDF, XLS, and CSV reports and alerts from your Elastic Stack applications or in Grafana applications, go to www.skedler.com, where you can find tons of information about monitoring, microservices environments, Elastic Stack reporting and alerting, and Grafana reporting. While you're there, you can also download a 21-day free trial and see for yourself how simple and effective reporting and alerting can be. So thank you for joining me. I'll see you in the next episode.